Lesson 4.3 is about rotations. So once again, we're kind of working our way through this chapter of transformations. And this is going to be our, again, kind of our third one. So we've done translations, we've done reflections, and now we're doing rotations, okay? So really, I think you guys kind of have an idea of what a rotation is. So if you think about a rotation, you're taking this fixed point here, and ours are going to be on graphs, so they always use ours on the origin, okay? But you take this fixed point, and you basically take the item, so like a triangle or whatever the shape may be, and you just kind of turn it or you rotate it. So sometimes if you're having a hard time visually seeing things, a piece of tracing paper works really well because it's really thin, you can see through it. And so what you do is you trace the triangle. And so here's our original triangle. And if we put our pencil here at the center of rotation, notice if I kind of just turn it, notice how they match up. So when we talk about rotations, we often talk about these as a turn, okay? So the first one we did was a translation, which was a slide, essentially. Then we did a reflection, which I kind of call like a flip, because you're just flipping it over. And then this one today, the third one, is a rotation. And then the next one tomorrow is a dilation. So those are the four that they're having you guys go through, okay? This angle that we're turning it at is called the angle of rotation. So you'll often hear about this angle. Now, in our chapter right now, our angles are always going to be positive. There are negative angles of rotation, but actually what a positive angle actually means, if you think about an axis, like the grid, so this is your X and Y axis, this is quadrant 1, 2, 3, and 4. So a positive rotation would be going from, say, quadrant 1 towards quadrant 2. That would be a positive turn. If you were to go negative, you would have to go in like against the quadrant. So maybe from quadrant 1 towards quadrant 4. So in our class, they're going to stay positive, but I just want you to know that there are negative rotations out there, okay? So on this first one, number 1 here, they want you to explore with a 90 degree. Partly the reason why they want you to do 90 degrees is because it's easy to draw, okay? If you look down below here, you'll see a very similar pattern to what we did yesterday. And when we have these rules or shortcuts for our 3 angles. So notice we have 90, 180, and 270. Now notice over here, you'll see these are X and Y's instead of A's and B's like they were in the previous lesson. Again, don't always understand the book, but it is what it is. So I want you to see if you can explore. Now, I don't have a protractor here, but I do have a pack of sticky notes. And so what I'm going to do is I can use this corner right here as a 90 degree. Now remember, you're going 90 degree about the origin. Remember that your lengths are always preserved. So I'll do like, well, I guess we can kind of do it together. But if you think about A, if we're going to turn this 90 degrees, so we have to go this way, because this would be quadrant 1, quadrant 2. Notice we can stay on the axis. So we're up at 3, so this would go over here at 3. So this would be my new location of A. So then let's just write down A was 0, 3, and now it became -3, 0. Okay? All right, let's do B. B is going to be a little bit more challenging because notice it's not on the axis. So what I'm going to do is I'm going to connect B to the center. Okay, so I just kind of connected B to the center there. And now I'm going to try to draw a perfectly 90 degree angle. And so what I'm going to do is I'm going to use my sticky notes here and I'm going to try to just line it up and make a 90 degree. And then I'm going to try to just trace it on this side. Okay, like that. So hopefully that's 90 degrees. It may not be perfect, but it should be pretty close. I'm going to put my tracing paper over top, and I'm going to put B right here. So this is B. I'm going to hold my pencil. And now when this stops, where it hits the line, That's where the new location of B should be. So if I kind of look through the tracing paper, it should be at negative 5, 4. So negative 5, 4 would be my new location of B. So I'm going to write down my old location, which was 4, 5, and my new location is negative 5, 4. So you might be kind of noticing the pattern, because remember, the patterns are really important when we go down below. So we would do the same thing with C. Where's my sticky notes here? Okay, so we would take C and we would connect it through the origin. And then I'm going to try to make a 90-degree angle. Oh, look at that. I'm not 100% sure if those are perfectly 90. The line that goes up to B looks awfully close, but I'm just going to go ahead and trace mine. Again, this is partly the reason why we don't, using tools like this, it may not be 100% accurate, but it's pretty close. Okay, so I'm going to mark C, and I'm going to put my pencil here, and I'm going to spin it until it hits the line. And it looks like it's right here. So, looks like it's right there. So let's write down the C again, like we did before. So this would be 1, 2, 3, negative 3. And maybe you can guess right now what the new location is going to be, okay? So if you kind of follow the pattern, what I'm noticing is that they switch and that it becomes negative. Now it's hard to see with 0 because 0, you can't do opposite. So let's see. They switch, but see how the 4 stayed. So I'm kind of thinking that the y is going to become negative, but the x stays the same. So let's look at our new C. That's 1, 2, 3. 1, 2, 3. So 3, 3. So our rule was correct. So we could go down. Actually, I could trace this in too if you wanted. So sometimes what you might notice if you kind of look at these two triangles, do you see how they almost kind of land on top of each other? Sometimes that happens and sometimes it doesn't. It just kind of depends on how the original was drawn. But in that particular case, like I say, it does kind of land on top of itself. So this is kind of the rule. So we have opposite y comes first and then we don't change the x. So anytime you're given a problem with 90 degrees, you can either do what I just did, but you can kind of see how it's time consuming by tracing it out and using a corner as your 90. You can try to draw it out, or you could just apply the rule, which I think is a little bit faster. So if I was doing number 3 down here, probably I think what I would do is I would just go off to the top of my paper here and I would write down the coordinates for my triangle. And then I think I would just apply the rule and regraph it. I wouldn't try to draw all these lines on because it can be just a little confusing. So let's just quick do that. Now I don't love this picture because if you notice again, this graph is by 2's. So if we look at S, it's technically at -1. And then this is 2, 4, and then half would be 5. But that's okay, we can still do it. If we apply our rule, this would be -5 and then -1. Remember, the x doesn't change. So 2, 4, negative, and then half, -1. So this would be my new S location, okay? So if you want to pause the video here, I'm going to go ahead and fill in my R and my T, and then you can check yours with mine. Looks like I've done something wrong because, oh yeah, this is supposed to be a -4. See, that triangle looks awfully big. Good thing I wrote in pencil. Okay. If you paused it or whatever you've done, here's my answer. Okay? It took me a second because I switch the X instead, and I was only supposed to switch the Y. So I just messed up on the R, but I did okay on the T. So must have had a little confusion in my brain. So anytime you do 90, that's what is going to happen. Now, 180 and 270, I could do another picture. Like I could go through here if you look at number 2, and we could do 180. And basically what you would need to do is you would need to pick a point. Now, L might be the easiest. Let's say you pick L. Actually, L might be the easiest. If you pick L and you were to draw a straight line through the origin, okay? So if you were to draw the straight line, whatever distance this is, you have to go the same distance this way. So your new L would be right here. So if we think about our old L, this is the original L. And then if we think about the new L, that one can be hard to see the pattern because notice the 2's are the same. So you definitely know they're opposites, but it's hard to tell if they're switching position. And I will just tell you, they don't. But if you want to try another letter, if you want to try M, M might be difficult too because it's both 1 and 1. You know, if you do M, this is going to be 1, 1. And if we do a straight line, M is going to land right here. So M is going to be -1, -1. So it's hard to tell if they're switching. But if you do J, because J has 2 different coordinates, I think that will be a better example. So -2 to 4. We know it's going to be opposite. So we know this is probably going to be positive and this is going to be negative, but we don't know if they stay in their spots or do they switch. So if you think about drawing a line through the origin, again, sometimes this can be hard even just to do a straight line, even with an edge of something. Because notice this isn't really like a solid box. So you almost need a ruler here. Or what I could try to do is if I use my tracing paper, and then this is the center. If I take my tracing paper, and if I flip it over, if I line the center up, notice J is right here. So there's my new location of J. So J becomes +2, -4. So now are you noticing the pattern? They're not switching spots. So the X and the Y, they don't switch, they stay, but they do become opposite of whatever they originally were. So now let's just do the rule for K. So K is -5, 1. So now that we know the rule, that we can be sure, because those numbers up there originally were harder, we know we don't change their order. We just do opposite and we do opposite. So now we just need to graph that. So 5, -1, and here's my new K. And another way to check if you're not sure, you can see I kind of keep grabbing this tracing paper, is if you take your not your triangle here, your square, whatever your shape is, it doesn't really matter, whatever the shape is. If you put your pen or pencil down at the center and you rotate it, you'll be able to tell, does it match up? Okay, so that's how you'll know. Now you can see my letters are backwards because I rotated it, but you can see I have J to J, I have K to K, I have L to L, so I know that I've rotated it correctly. So again, I think it's easier if you just apply the rule than probably